Async SQLAlchemy promises better performance, but does it actually deliver? I built the same FastAPI CRUD application twice, once with synchronous code and once with asynchronous code, and ran real benchmarks. The results show exactly when async wins and when synchronous wins. Today we are comparing the synchronous and the asynchronous FastAPI logic and show the real performance differences. So I will cover the FastAPI and database setup, the synchronous versus asynchronous endpoint setup, how def and async def functions work in FastAPI, and run the performance test and show you when to use synchronous and when to use asynchronous. First of all, I'm going to show you the project setup. I'm using a basic FastAPI app. I have the async database, which you can see here. I'm creating an async session, which we can use to query the database, and I create the tables with synchronous execution. I have the same setup for the synchronous database, but with a synchronous session. Next, I'm going to show you the bundles we're going to use for this example. I created a basic item with an ID, a name, description, price, created that, and updated that. In the main application, we're going to register the routers for the sync router and for the async router. And I will list on the read root endpoint which endpoints are available. I can open the Swagger docs UI, and we can see the synchronous CRUD and the asynchronous CRUD, both having the same endpoints which we can run. Now I'm going to jump into the synchronous router and into the async router. Now we can see on the left side our sync router and on the right side our asynchronous router. Like you can see, the endpoints are almost similar. For the synchronous code, we use create item, we add it to the session, and we commit to the DB. After that, we're going to refresh the item to get the updated and posted items. So we can return this to the frontend, for example. On the right side, we have almost the same code. We're going to create the item, add it to the session, and commit it. But this time we're going to wait for it because we're using an asynchronous endpoint. And then we also wait the refresh of the DB item and return the DB item. And the next endpoint, we have a get requests. A get request, we're going to query the item in the DB with an offset, a skip, and with an offset and a limit. And then we're going to return the items. On the right side, we have almost the same code like before. We're going to execute the query. We select the item, the offset, the limit. But this time we will wait for this call and return the results as a scalar and return all of the results and return the items to the frontend or to where we handle the request from. The next one is to get a specific item with a specific item ID. We're going to query the DB again. Like the first, we only get the first because we query a specific item. And if we don't find the item, we're going to return a 404 error not found. Now we're going to go into the asynchronous code. We're going to execute the query again. And this time we're going to scalar to one or none. So if no item is found, we're going to return none to the item variable. And if we have no item, we're going to return an error again and return the item. Now we have an endpoint to update the logic, which is almost the same. I won't go through again. And again, scalar to none because we update one item. Or if we don't update an item, we get none returned. We also have a delete endpoint, which is using the same logic. We're going to return. We have the item, and if not item, we're going to return that the item is not found. This time we have to await the delete and await the commit again, and we return none because we delete the item. Same side on the synchronous, but this time no await because it's running synchronous. To make this work, we have to make sure that we use synchronous and asynchronous database driver for Postgres. You can see we have the normal database URL with Postgres driver, and for the asynchronous, we need to use async PG. I run the database in Docker, so I will start up the database with Docker Compose. Now that the database is up, I can show you that we set up the FastAPI application for development. We start the server with Unicorn. Now that the server is up, I go back to my frontend URL and we can see the Swagger UI. Now we can see the sync items, and for synchronous items to create an item, and we can see the endpoint for create item async, which both have the same functionality, just being sync and being asynchronous. Now let's jump in and explain the difference between asynchronous endpoints and synchronous endpoints. I'm going to go into the router, the sync router, and explain. With the normal FastAPI function, it's using a thread pool. Each request gets a thread. When that thread hits the database input-output, it blocks the thread and just sits there waiting for the database to respond. So if you have 40 threads, for example, you can only handle for about 40 blocking operations at once. With the asynchronous endpoints, everything runs on one event loop thread, which you await. The function yields the control, and the thread doesn't block. So the thread can handle other logic and do other requests, and goes back to this request and processes as if the database responded. So FastAPI can resume your function, and one thread handle multiple thousands of requests this way. So it's not blocking this single thread. So we can see this, for example, this one yields, so the thread can be used, and this one will block the thread. So it has to spin up multiple threads to handle different requests. I've created a quick test script, which you can see here, to test the performance, which I will run, and I will show you the result of the request when it's finished. So let's just run the script and test out the performance. You can see the script, I'm going to execute it, and this one is going to run the performance test between synchronous and asynchronous endpoints. Now that the test script finished, we can see the results. We can see that on synchronous operation one at a time, we can see that async endpoints are 10,000% 0.7 faster. On batch concurrent, so 50 requests in batches, the asynchronous is 47% slower and the synchronous wins. And on a mixed workload between reads, writes, and updates, we can see that this synchronous is faster and asynchronous is 136% slower. And on single items, also the synchronous is winning by 1 millisecond. So why does synchronous win in most conditions? We are testing on local hosts, so that means the database is literally just almost no latency away via Docker. So each request takes about 15 milliseconds total, and async advantages comes from yielding during I/O wait, and in this case we don't have to wait for the database because it's on the same network. But when there is barely any wait time, async context switching overhead becomes significant, so the context is switching between the threads and it doesn't provide any benefit because there's no time to wait and switch the context really. And the next factor is that both have 20 connections in the pool, so the database can pool, but only up to 20 connections. Under concurrent load, even async can't help if all connections are busy, and we are hitting the database limit, not the framework's limit. The next factor is that Postgres serialize writes operations for consistency, and we are doing creates and updates. The database itself becomes the bottleneck, and no amount of async magic can make the database process write in parallel. So let's conclude and what you need to use when. So if you have high concurrency, you should use async, and if you have a lot of network input-output and multiple input-output operations like waiting for different APIs, and then async would be a benefit. Or if you use real-time data and WebSockets, or if you have a microservice architecture. And you should use synchronous if you have simple create, update, read. And if you have CPU intensive task, which should just block the thread, and there's no logic in changing the context and changing the thread. And many legacy libraries also depend on synchronous code. So that's the case when you should use synchronous code rather than asynchronous code. So what we have learned is that async versus sync is about I/O handling. If you have a lot of input and output, you should use asynchronous. The code, which you can see is in synchronous and asynchronous routers, almost the same. So it isn't that much overhead to add asynchronous endpoints. Also, the performance depends on the context, and you should choose based on requirements. If you have CPU-intensive endpoints, you can use the synchronous and don't block the thread. And make sure that if you use asynchronous endpoints, that you don't use blocking synchronous code. So make sure you actually use the await for the DB calls, or don't use code which is blocking and use it without await. So if you use time.sleep, you would block the thread and it couldn't switch, and it's running on one event loop. So that would make a big performance impact. So if you want to develop your app, it could make sense to start with synchronous and adapt await and synchronous endpoints in going further. But it could also be a good implementation to already start with asynchronous code because it's not that much overhead. I will be uploading this code to GitHub, so you can check it out yourself and expand it if you want. If you want to read more on that, I can recommend the FastAPI docs. And if you are building your own app and want to start a software as a service, for example, or any other API without using a lot of templates, you can check out my FastAPI template, which I called FastLaunchAPI. I will put also the link in the description, and from that I wish you good luck learning and implementing the logic in your own FastAPI applications. See you in the next video.